Members of the community surrounding coal energy plants in North Carolina are currently suffering from an absence of clean water due to water contamination from coal slurry. As the energy plants burn the coal to convert to energy for the neighboring towns, ash fly is mixed with the water that is used and transported to its citizens for day-to-day usage.
In order to combat this problem, we developed a solution we like to call Filtrarisma. And what it does is incorporate 3 different solutions, which will be further explained later, in order to prevent the optimal method of dealing with this coal issue.
The method was the dewatering plant. Here we basically filtered out the coal ash from the water to produce water that is less contaminated.
The solution I proposed was a appeal of Act 630 that was proposed by Governor Pat McCrory.
The final solution we proposed was actually the reinforcing of the individual components, which was namely the pipes as well as a storage facility. So the main 3 criteria we considered when developing our final solution involve longevity, cost, and safety. Our final solution is actually a combination, as previously mentioned, of the 3 mentioned methods. It involves a reinforced reservoir, support pipes, as well as reinforced pipes in general, and the dewatering plant in the middle.
The dirt water being poured into the first component represents the coal factory, which is then being transported to the dewatering system, where the water and coal ash will then be filtered out to then go to our last component, our reservoir that will hold our then clean water.
When considering the math science theory component of the project, we found multiple sources that provided information we needed to obtain a final answer. We found that roughly 7 to 50% of the coal is removed in the dewatering process, and roughly 40,000 tons of coal is produced each year by a coal company, as taken from a 2014 report from the Dan River Science Station. Comparing this with the local cost of coal being around $40, we got an approximate value of $700,000 revenue being generated from the dewatering process per year that it's in action. Okay,
The components of our model. The first component I'll talk about is a reservoir. A reservoir is going to cost about $250,000. Our dewatering plant is about $2.8 million, and the maintenance of this plant comes in at about $15,000 per year. The piping will cost about $30 per foot, and it all totals to about $3.25 million.
When researching the patenting and trademarking for our product, Filtrarisma, we considered multiple things. Mainly though, we considered what the name of our product was, as well as the individual components that make up the product. First, using a representative of the dewatering process, a patent that was first filed on October 2010 was found to not only use the dewatering process, but propose an improved model where the coal was collected via use of automatic scrapers. Moving on to the reservoir, we found that there was a patent created in April 2013, which not only proposed a simple reservoir, but also proposed a reinforced lining that prevents any liquids or solids escaping the container. Other than the individual components, however, we found that there was no existing patent which was filed reserving the name Filtrarisma, which is the name, once again, of our product.